Let us look at the next section, students. This section contains 4 questions. Each question has 4 options in which the matching with respect to list 1 and list 2 is given. We have to select the correct match. Let us look at question number 33 now, students. Match each set of ions from list 1 with the confirmatory test in list 2. So we can talk about the list 2, students. We can start with the list 2 first. Let's look at the first option. So in the first option, there is white precipitate with ferrocyanide ions. So if we look at the options on the left, we can clearly see that there is only zinc, which gives a white precipitate with the ferrocyanide ions. So we have zinc 2+. So the correct matching with Q is going to be 1. If you look at the next option, deep blue color with ferrocyanide ions. So looking on the ions given in the left hand side, we can clearly see that only the Fe3+ ion is going to give deep blue color with ferrocyanide ions. So we have R match with 2. If we talk about the third option now, white precipitate with AgNO3 solution, which is soluble in dilute ammonia. So it is AgCl, the white precipitate. So S will be matched with 3. If we talk about the fourth option now, which is that there is a blood red coloration with thiocyanate ions. So Fe3+ gives this test. So R will be matched with 4 as well. If we talk about the fifth one, chocolate brown precipitate with ferrocyanide ions. This is the test for cupric ions. So P will be matched with 5. And if we talk about the sixth one, which is a reddish orange colored gas is obtained when heated with K2Cr2O7 with concentrated H2SO4. So this is the chromyl chloride test for the chloride ions. So S will be matched with 6 as well. So this is the correct match for the species given, students. And we can clearly see that this is given correctly in the A option. So for this question, we have to mark the correct answer as option A. Let's look at the next question now, students. Question number 34. We have been given some reactions in list 1 and the reagents have been given in list 2. So we can start with list 1 this time. So we have a vicinal diol. The vicinal diol is cleaved into the corresponding ketone. So this can be done by either lead tetraacetate or with periodic acid. So P will be matched with 2 or 3. If we talk about the second reaction is the conversion of toluene into benzaldehyde. So this can be accomplished by the chromyl chloride. So we have Q matched with 1. If we talk about the reaction given in option R, we can clearly see that there is a reduction of a carbonyl and it is converted into CH2. So this will be achieved by the Wolff-Kishner reduction, which is given in the fourth option. So R will be matched with 4th. And if we talk about the reaction given in option S, we have a ketone converting into an alkene. So students, this can be done by the Wittig reaction, the reagent of which is given in the 5th option, that is a phosphorus halide. So the phosphorus halide will convert this ketone into an alkene. So S will be matched with 5. So we now have the correct matching for question number 34. And we can clearly see that for this question, we have to mark the correct option as option C. Let us look at the next question now. Question number 35. Match the effective atomic number values given in list 1 with the complexes given in list 2. So the first complex is PDNH3 6. So if we talk about PD, so Ni, PD and PT, they belong to the same group. So Ni is 28. So it has to be 46. And there is PT also involved. So we have to add 32 in this case. So it will be equal to 78. So if we try and figure out the effective atomic number of the first complex, we have PD. So PD has an atomic number equal to 46. It is present in a state of +4. So 4 electrons have to be subtracted. Plus there is a donation of 12 electrons from the 6 ammonia ligands. So when we add this, we have a total effective atomic number equal to 54. Let's talk about the second complex now, Fe. So Fe has an atomic number equal to 26. It is present in a state of +2. Plus there is donation of 12 electrons from cyanides. So this is equal to 36. Let's talk about the third option now, students. Ni, it has an atomic number equal to 28. It is present in a state of +2. Plus it gets 12 electrons from the ligands. So this will give us a value equal to 38. If we talk about the next complex, which is the CONH3 6 3 positive. So cobalt has atomic number 27. It is present in a state of +3. It gets 12 electrons from the ligands. So this is also equal to 36. If you look at the next option, Ag. So Ag is present in the copper family. So we have copper, silver, gold. So the atomic number of Ag is going to be equal to 47. It comes just after palladium. So it is 47. It is present in a state of +1. Plus it gets 8 electrons from the 4 ligands. So this is equal to 54 again. If we talk about the next complex, we have PT. So PT, we had seen that the atomic number was equal to 78. So 78 electron of its own. It is present in a state of +2, plus it gets 8 electrons from the ligands. So this will give us an effective atomic number equal to 84. So if you look at the entries given in list 1 now, 36 will be matched with option 2 and 4. 54 will be matched with option 1 and 5. 84 will be matched with the 6th option, whereas 38 will be matched with the 3rd option. So we now have the correct match for this question. If you look at the options given to us, we can clearly see that the correct answer to question number 35 is option B. So we have to mark option B as the correct answer to this question. Let us look at the next question now. Question number 36. Match the products given in list 1 with the reactions given in list 2. So if you look at the reactions first, we'll start with list 2 again, students. So this dicarbonyl compound is subjected to the aldol conditions. So there are two possibilities. There are two types of alpha hydrogens. And if you talk about the attack happening, there will be a formation of 5-membered ring when this carbon ion attacks. Whereas the carbon ion generated here will lead to the formation of a 7-membered ring. So 7-membered rings are not generally formed. So we have to proceed in this fashion. So we're going to have the formation of this compound after the dehydration process, of course. So this will be matched with the Q option. If you look at the next option now, we have an alkyne. The alkyne is subjected to hydration. So upon hydration, this will lead to the formation of acetaldehyde, and that acetaldehyde molecule obtained is again subjected to the aldol conditions. So the acetaldehyde, when subjected to aldol conditions, is going to generate this structure. Okay. So if you look at the options given to us, we can clearly see that P option will be matched with the second option. If you look at the next option, the third and the second option are the same. Here also there was formation of acetaldehyde. Here the examiner has started with acetaldehyde. So this will again lead to the formation of the same compound. So the P will be matched with 3 as well. If you look at the next option, again there is a case of intramolecular aldol. So there is a possibility of a 6-membered ring versus an 8-membered ring. So the 8-membered ring will not be formed. The carbon ion generated here will attack. So we're going to have the formation of this structure after the dehydration. So we have to match option R with the 4th option. If you look at the 5th reaction given to us, in the 5th reaction we have the alpha hydrogen here, and the receptor will obviously be benzaldehyde as it does not have any alpha hydrogen. So this is going to lead to the formation of PH, CH, CCH3, CO, and there will be an H in this case. So this is then subjected to reaction with LiAlH4. So the LiAlH4 also reduces the cinnamic system. So it is going to reduce the double bond as well as the C double bond O. So this is valid only in case of the cinnamic system in which the benzene ring is also in conjugation with the double bond and the carbonyl compound. So we're going to have the formation of an alkene over here, PHCH2 CCH3 followed by CH2OH. So this will be matched with the S option. So S will be matched with 5, and if you look at the 6th reaction, the 6th reaction is also the same as the 5th reaction. After the aldol conditions, this product is obtained in the 5th reaction. Okay. So the S option will also be matched with the 6th option. So students, if we look at the correct matching for this question, we can clearly see that we have to mark the correct answer as option B. So this is it for today, guys. I hope the solutions were clear to you. Thank you.